So the next section is on properties of logarithms, which we're going to be talking about tons of properties that are associated with logarithms, which you already explored some properties of logarithms, but now we're going to go into much more depth on other properties and how we can incorporate them into a logarithm problem. So the first property we're talking about is the product property, which the word product, which you probably already know, means multiplication. So this property says if you see multiplication within one log, okay, so within one log, if there's multiplication, okay, we can split up each piece of the multiplication into their own logs and separate them with an addition sign. Okay, and if you notice, whatever the base of the log was in the original singular log, okay, is carried over into each of these logs. Okay, so again, multiplication in a log, you can separate it with an addition sign and put each piece of the multiplication in its own log. Okay, and again, you can only do this if the bases are the same. Now, the reverse is true as well. If you see two logs added together, okay, you can combine them into a single log by multiplying each piece of the log together. And remember, the bases have to be the same. So if this was a different base, if this was not base C, we cannot use this property. Okay, now be careful. Okay, this is not what I'm saying. This is not saying log A times log B. Okay, log A times log B never, ever, ever equals log of A plus B. So you can't like reverse this property around. You can't change the single log into addition and the separated logs into multiplication. So just be careful. Make sure you understand the difference. Alright, so in example problem 1, we are expanding the logarithm, so we are starting with a single logarithm, and we're going to make it into more than one logarithm by splitting them up with addition signs using the product property. Okay, so go ahead and pause this video and watch example 1, parts A and B. Alright, so example problem 2. This time we're reversing the process. If you notice in the example, we have more than one log listed, and if you notice, each log is separated by an addition sign, which means if we reverse the property, if you have separated logs that are added, you can combine them into a single log with multiplication. Okay, so we will be reversing the property, and we're also going to simplify. So we're going to be solving the logs like we did in the previous section. So remember, logs are a value. They're technically an exponent in an exponential, is what you solve for when you solve for a log. So you will combine them into a single log and then solve for the value of the log. So go ahead and pause this video and have a wonderful time working example problem 2. Now, the next problem is called the quotient property. So quotient, which you guys are so smart, you probably already know it means division. So if in a singular logarithm there is a division symbol, okay, that means you can separate each piece of the log using a subtraction symbol. So if you notice here, again, all of our bases are consistent. You have to have the same base in order to use this property. Okay, and if you also notice, the numerator of the fraction, the number on top, goes in the first log, and the denominator of the log, the bottom part of the fraction, goes in the second log. Okay, and these are separated by subtraction now. So product property is addition, quotient property is subtraction, so be careful. Also, the reverse is true. So if you see two singular logarithms that are subtracting from one another, you can combine them into one log through division, which the first number is always the numerator and the second logarithm number is always the denominator. And again, be careful. Do not interchange these rules. So if you see subtraction in the log, that doesn't mean you can divide two separate logs. So this is not even true. So don't even try it. The reverse is definitely never, ever, ever true. So just watch yourself. Okay. So, like we did in example 1, we will be expanding singular logarithms using the quotient property. So starting with one log and separating them into more than one log. Okay, so go ahead and pause the video and have fun. Now, example 4 is kind of like example 2. Not only are we going to express this as a single log, we're also going to solve for the loggers to simplify it. Okay, so if you see here, we have more than one log listed, which if we reverse the rule, remember, if you have more than one log separated by a subtraction symbol, you can combine it into one log with division. So we will be reversing the rule this time and also solving for the value of the log. So go ahead and pause the video and watch example 4, parts A and B. Now the power property. Power usually is associated with an exponent, so this rule also is associated with the exponent. So if you see here, if you have log base c of a raised to an exponent, that's the same thing as putting that exponent in the front of the log. So I kind of visualize someone like shoving the exponent down to the very front of the log. So your exponent you can move to the very front of the log. Those two mean the same thing. Or the reverse is true. If you have a number in front of the log, you can move that bad boy up to the exponent. So either rule is true. Okay, so you can go one way or you can reverse it going the other way. Okay, now the b can be on the outside of the log like so, or it could have been in the parenthesis. Okay, those two mean the same thing. So that exponent could be outside of the parenthesis or inside of your parenthesis when you're doing this. Okay, so for example 5, you're going to be rearranging the logarithms using the power rule. So you'll be moving the exponent where the exponent can be moved to, which what we talked about in the front of the log, or you can move the number in front of the log if you reverse it to the exponent. So in example 5, parts A and B, you will see how to use this property. Here's a funsie, which we will have a fun time doing this later on in class, so don't worry about that. So now, this is when it all comes together. We will be expanding the logarithm using all the properties we have talked about. So we are starting with single logarithms and using the product, the quotient, and the power property. We will write this out in multiple logarithms. Okay, so there'll be lots of logarithms. So we're going to just expand it. We're not solving anything. We're just going to write it in multiple logs, not just with one log. So go ahead and pause the video and have a blast working example problem 6. Here's our funsie, which the fun times will be held later on, don't you worry. Okay, and now we are reversing what we did in example 6. So we have a bunch of logarithms written next to each other. Okay, and we are going to write this as one logarithm using all those nifty properties we talked about. And then, not only that, we will simplify. So we're going to solve for the log. Okay, so go ahead and pause the video and watch example 7, parts A and B. Here's our funsie, which the funsies will be held later on. Okay, so change of base rule. Now, this rule is kind of outdated because the reason why we use this, which I'll kind of explain in the example video more in depth why. Okay, but the reason why we use this, on your calculator, if you look at the log key, which is on the outside of your calculator, which in this example problem I will show you what that looks like. So if you're like, what are you talking about, Miss Long? Just watch the next example video and I'll show you what I'm talking about. But there is a log button that you can see as one of the buttons on your calculator. Okay, you don't have to go into like the math button to get to it. Okay, so if you use the log button, if you push the log button, it does not have a base, which if you see that, that means that the base is 10. So it used to be that calculators only had base 10 on the calculator. You can only work with logs on your calculator in base 10. Okay, so we had to work around that when we had something that wasn't 10. So this is kind of a rule you can use to change the base to whatever you want. So if you see here, we started with log base c of a. Okay, but if we're going to type this in our calculator using the log button, okay, we can't have base c. The only base we can have is base 10. Okay, so the way we rewrite this so we could get base 10 on the calculator, these are equivalent. So you could, log base c of a is equivalent to log of a divided by log of c, which is your base. So the way I kind of remember it, the a is slightly higher up than the c, so the a is going to be higher up than the c in your division. Okay, so it's always log of the number inside of the log divided by log of the base. Okay, and you don't have to just change it to base 10. If you ever need to, for some reason, change your log to a different base, okay, you could have changed this to log base 9 of A divided by log base 9 of C. And then your log would now be in base 9 instead of whatever base C is. Okay, so this is just a way for you to change the base. Okay, but the newer calculators, which again, in the example video, I will show you this on the calculator. The newer calculators, you can actually type in a log with any base. So a lot of times this rule is not used. Now when you get to calc or pre-cal, you might need to change a log to a different base for a different reason. Okay, other than just you need to type in the calculator, but this is when it was mostly used. So, oh, sorry guys. And again, like I've been warning you, okay, these are not true. So you can't just say log of A divided by log of C is the same as log of A divided by C. We already know that log A divided by C equals log of A minus log of C using the quotient rule. So just be careful, dividing in the log does not mean dividing two separate logs. So just watch out for that. Ah, sorry guys. No, stop that. Okay, so example 8. We're going to rearrange the log base 4 of 5 using the change of base formula, and we're going to find the value of the logarithm. So we're going to approximate the log without having to solve for it. So your calculator will actually give you a decimal form of the logarithm. Okay, so I'll show you both ways. I'll show you just how you can type this in on the newer calculators, and then I'll also show you how to use the change of base rule using just the log key on your calculator, which if you don't have a newer calculator, the way I'm going to teach you, you can use on your calculator. Okay, now example 9. It is not using the change of base rule, even though it kind of sounds like it. Okay, basically we're going to solve for the value of these logs like we've been doing and like we did in the previous section. Okay, but this time it's much harder to get the same base on both sides when we convert that bad boy into an exponential. So these examples are what you do when it's not as easy to make the same base. You still will be able to get the same base, but it's a little bit more challenging. So go ahead and pause the video so you can work the more challenging problem on example 9. Which, remember you guys, the harder the problem, the more exciting the problem. So you guys are going to have so many fun times. So many. Okay guys, so the last property we're going to be talking about. I know we talked about a ton of properties, but we saved the best for last. In my opinion, this is one of the easiest properties. So, the inverse property. So inverses, as we've been talking about, are things that are opposites of each other, or they undo each other or cancel each other out. So like some examples of inverses are like addition and subtraction. They cancel each other out. Okay, multiplication and division. Like when we move things from one side of an equation to the other, we do the opposite operation so they will cancel each other out. So we can undo the property. Okay, so we have some inverse properties for logarithms and exponentials. So logarithms and exponentials, like we found out, are inverses. So if a log is sitting right next to an exponential, they will cancel each other out. Okay, so let's look at number 1 right here, the first one. So if you see here, we have the same base. First of all, you must have the same base for this rule to work. Okay, if this was C and this was a base of, I don't know, D, okay, this would not work. Okay, so if you see here, we have log base C of C raised to the x power. So this is an exponential where the base is C, and this is a logarithm where the base is C. So if you see those consistent bases right back to back, they will cancel each other out, which means you're only left with the x. Okay, so if you ever see common bases right next to each other and one's a log and one's an exponential, everything cancels out except your exponent. Okay, kind of the same idea with this one. We're kind of reversing the rule, but the same thing applies. So we have an exponential with base C raised to the power of a log with base C. So if you see here, we have those same bases repeating. So if you ever see a base of an exponential, that's the same thing as the base of a log, and they're right next to each other. Guess what, you guys? They cancel each other out, and all that would be left is your x. Okay, so the exponential and the log cancel out, but either the exponent or what's in the log does not cancel out. So either of these would equal x. So example 10 will incorporate this problem, but you will have to do a little bit more work to get to the answer than just this. I had to make it more challenging, you guys. This was just way too easy. Okay, so we're going to work example 10, and this is actually the end of the video. So you can go ahead, this is our fun thing we'll be doing later on. Okay, so go ahead and pause the video and have a wonderful, amazing, incredible time working example problem 10, which is the last example problem.